Welcome back to the DSA solutions. Today we'll see to some problem from binary search tree topic. So here what you have to do, you have given a binary search tree and an integer key. You have to find two node. If you sum their node value, it is equal to k. If you are getting this two node value, just return true, else return false. This question we have used four helper method. One is find minimum. This will return the minimum node value from BST. Another method is find maximum. This will return the maximum node value from BST. Next method is find next greater method, which will help us to move a smallest pointer of a node. That will help us to get the target sum when current sum is lesser than the target sum. Another method is next method we are using find next smaller method, and this method will help us to move our largest pointer to get the target sum when current sum is greater than the target sum. Let's understand this question step by step. So find leftmost node having the smallest value. So to find the node with the smallest value in binary search tree, start at the root node and continuously move to the left child until you reach a node with no left child. So start with 5, then move to left 3, then from 3 move left again to 2, then node 2 has no left child, so it is the leftmost node. So we can say the smallest value in this tree is found at node 2. So find the rightmost node having the greatest value. So to find the node with greatest value, start at the root node and continuously move to the right child until you reach a node with no right child. So start with node 5, then move to 6. From node 6 move to again right 7. So node 7 has no right child, so it is the rightmost node. So you can say the greatest value in the tree is found at node 7. Consider one example. You have given target sum 9 and you have given this binary search tree. So you have to check pair is available or not where target sum is 9. So we'll start with uh, from smallest element and greatest element 2 pointer. So we'll sum up for these 2 pointer 2 and 7, it is 9. Yeah, so sum matches to the target sum, so we can say 2 7, this 2 node pair is available, is so we can return true. Consider one more example where you have given a target sum 10 and this is the binary search tree you have given. So let's check any node pair, any two node pair is available or not where target sum is 10. So let's start with 2 pointer, smallest element and greatest element. So smallest element 2, greatest element 7. So if we sum up these two node values 9, and you can see our target sum is 10, but if we sum this is 9, so 9 is lesser than 10. So in this case we'll adjust our pointer, we'll move our smallest element or we can move our greatest element. So first we'll see in smallest element side, let's find next greater element of 2. So next greater element of 2 is 3. So if you sum 3 and 7, this is 10. And if you go right side and move your greatest element, so find the next smallest element of 7, this is 6. So if you sum 2 and 6, it is 8. So 8 is lesser. So you see, if you initially find some sum is lesser than the target sum, then always you move your pointer to smallest element side. When you find next greater element for smallest element. Try to add a value and check if it is target sum or not. Consider one more example where target sum is 11. So initially smallest element 2, greatest element 7. If we sum 2 and 7, it is 9. So 9 is less than target sum 11. Since the sum 9 is less than 11, so we'll move the smallest pointer to the next greater element. So the next greater element of 2 is 3. Now we'll consider smallest element 3 and greatest element 7. So if we sum 3 and 7, this is 10. So 10 is still lesser than 11, target sum. So we'll move our smallest pointer to the next greater element. So the next greater element of 3 is 4. Now consider smallest element 4 and greatest element 7. So if you sum 4 and 7, it is 11 and target sum also 11. So it matches. So you can say we found the pair. So you can return true. Let's understand how we can find next greater element when sum was not matching with target sum. So initially the smallest element was 2 and sum was not matching, so we are trying to find the next greater element, which is 3. So how we can find this 3? Let's start with root node 5. So compare this smaller element to 2 with 5. So 5 is greater, you can move to left is 3. So again compare 2 with 3, 3 is greater. In this point 3 is the next greater element. Then we checked the sum with 3 plus 7, 10. It was still lesser than the target sum, so we checked how to find next greater element of 3, which was 4. So to get this 4, let's understand how we find. Start with root node 5. So compare this 3 with 5. 5 is greater. Then move to left. 3 is with 3. So you can move to right. So 3 is with 4. So 4 is next greater element. And update this smallest element 4 for your next pair consideration. So now our smallest element 4 and greatest element 7. So if you sum, it is 11. So it is matching with target sum. So you can return true. The coding part, let's implement find minimum method. Find minimum method will find the smallest value node. So start from the root and traverse left until no more left children exist. Then next method, find maximum method. This will find the largest value node in the BST. So starting from the root, traverse right until no more right children exist. Next method is find next greater. So this will find the smallest node whose value is greater than a given value. So this method is useful to adjust a smallest pointer when current sum is less than the target sum. We'll start from root. If the current node value is greater, move left, else move right. And while moving left, just take that node value as a next greater element. Your next method is find next smaller method. This will find the largest node whose value is smaller than the given node. So this method is useful when to adjust the largest pointer when sum is greater than the target sum. So here we'll traverse the tree from the root, and if the current node value is smaller, then move right and take the next smaller node value to node value. Assign this node value to next smaller node value and move left else. So next one is find target method. This will determine if there are two nodes in the BST that sum up a given target value. So here we will be using two pointers, smallest, largest. We'll traverse and find the pair of node. So what we'll be doing here, we will initialize the pointer smallest and largest node, and we'll sum their value and compare to the target. If sum is not matched, then we'll adjust pointer based on whether the sum is less than or greater than the target until match is found or pointer met.